everyone to preparing for data publishing standards and disciplinary repositories. My name is Sophia Lafferty-Hess, and I'm a research data management consultant within Duke University Library Center for Data and Visualization Sciences. And I am joined today by my colleague, Jen Dara. Jen, do you want to say hi?
Hello.
All right. So to quickly introduce the center where Jen and I work, the Center for Data and Visualization Sciences, or what we call CDVS for short. We have a team of data experts that provide both consulting and instruction on a variety of topics that support data-driven research. So this includes things like data science, so understanding and using programming languages like R and Python, GIS and mapping, data visualization, and data management. So again, our main services is providing consultations by request. Our consultation services are free to anyone within the Duke community. So we serve the campus and the health side. Another big thing that we do is instruction and training throughout the semester. So we are pretty much wrapping up our workshops for this semester, but we will be releasing our new schedule of workshops in mid-December for the spring semester. We also have on our website a large amount of recordings from past workshops, as well as access to slide decks and other kind of asynchronous learning materials if you're interested. All right, so we always like to start our workshops with what we hope to impart upon you. So our learning objectives today is first to understand the context of data publishing and growing trends in academia towards more open research and scholarship practices. We're also going to spend some time identifying best or good practices for data sharing related to metadata and data standards, as well as the use of repositories and data citation practices. And then again, we're going to have an exercise where you will practice assessing repositories to determine if they actually meet some of these standards and guidelines for data publishing, as well as match different researcher use cases. All right, so I'm going to begin really briefly by placing this idea of data publishing and data sharing in a broader historical context of scholarly communications. So the Philosophical Transactions of the Royal Society was the first scientific journal and began publishing in the mid-1600s. And since that time, we have seen journal articles become the method for communicating results within scientific and scholarly research. Fast forward to the 20th century, and a key thinker, Vannevar Bush, through his writings, really pushed for the publication of scientific materials to extend the value of government-funded research and viewed the proper storage, maintenance, and access to what he called the record, which included data, as fundamental to scientific advancement. And then the internet arrives, and we now have the infrastructure needed to disseminate and share knowledge with the world, really creating that space for new modes of scholarly communication. And as we develop the infrastructure for new and novel ways to share information, we've also been seeing some noteworthy challenges, including what are being coined questionable research practices. So these are things like p-hacking or harking, which stands for hypothesizing after results are known. We also have what is called the so-called reproducibility crisis. So these two visuals come from a survey that Nature put out a few years ago, where they asked researchers if they thought there was a reproducibility crisis. You can see around 90% saying either a significant or slight crisis. And what I find even more interesting is this second graph, where they asked researchers, have you actually failed to reproduce an experiment, either your own or someone else's? So again, some of these challenges around reproducibility or questionable research practices are really rooted in our history, that traditional publications are the primary currency of academia, and they've really had a focus on things like positive results and have created an atmosphere where scholars need to publish quickly and often to be competitive. However, I also like to see where we are today as an opportunity for academia to kind of refocus our priorities and incentivize doing research in a way that enables reproducibility and normalizes practices that increase transparency and access, as well as innovative techniques for disseminating knowledge. So as we're considering these new strategies to address these challenges, we are seeing new modes of publishing arise. So for instance, some journals are now supporting what are called registered reports. So registered reports modifies the traditional peer review process. And instead of just submitting your article when it is finished for peer review and acceptance within a journal, instead, you would submit your idea and your study design earlier in that process, and then a journal would agree whether to publish your article regardless of your results, so whether they're positive or negative results at the conclusion of your research project. This also gives an opportunity for more iterative feedback throughout the research process, and this is pretty closely tied to some of the practices around things like pre-registrations as well. Another new type of publication that we're seeing are data journals or data papers. So essentially, this is where instead of publishing a journal article that describes the results from your research project, you'd actually publish a journal article that describes the data in depth. So you go into a lot more detail about your methods for gathering and generating and processing the data, as well as it's really got to focus on enabling others to reuse that data set. And a requirement for publishing in a data journal is that that data is actually accessible in an externally based public repository. So it's linked from the journal article, but it's actually being preserved and made accessible in that external data repository. And we'll be talking a lot about data repositories and giving examples of those today. So when it comes to actually publishing your data, and what I mean by that is the actual underlying spreadsheets and files and images that are the foundations for the claims that you're making in your research. So not just sharing a table in a journal article, but actually publishing that full data set. And this is what's being coined data publishing. So this is where that data are available through a public repository. They become a citable product. This supports reproducibility and secondary reuse. And generally, by publishing your data in this way, you're complying more with community best practices for sharing. So I just want to compare this to more what we think of like as informal data sharing. People and researchers have been sharing their data for a long time through things like saying the data are available by request, providing it when someone requests it through kind of a peer-to-peer sharing mechanism, potentially posting on like a personal or project website, or as supplementary materials with an article. But again, what we're kind of seeing is this trend towards really encouraging this more formal data publishing, both because it does comply with these good practices, as well as it gives researchers some more benefits for actually sharing their data. So we're also seeing various different stakeholders, particularly funders and journal publishers, requiring more extensive data management and data sharing as a way to provide more research transparency, as well as a better kind of return on investment for public funds used for research. So a big one recently is that NIH recently put out their new data management and sharing policy that went into effect in January 2023. We also have a new Office of Science Technology Policy memo. It's been coined the Nelson Memo, that's focused on requiring immediate, equitable public access to research. And this includes both research articles as well as data sets. And so this is telling all funding agencies that they need to update their plans for public access to articles and data, and those need to go into effect at the latest by 2025. So again, we're seeing kind of this regulatory strategy to change behavior towards more openness. I would say I don't know that we see the full impact of this yet, but we do know the trend is towards more of these policies coming out from both federal funding agencies as well as journal publishers. So taking part in more open research practices can make science and academia more human and break down barriers. So I'm actually just going to read this quote because I think it's really great. Said, the first time I dropped a reaction flask containing a precious potential anti-malarial My initial horror was compounded by the realization that I had to share news of this broken vessel with anyone reading my online notebook. But this honesty hopefully leads to increased transparency and a greater understanding of the human side of research. So I really like this quote because it highlights one of the challenges to openness, and that we don't always want people to see our mistakes. And, in a highly competitive academic culture, showing you're fallible or that science can get messy might not hold a lot of appeal, but I do think that it can help us build a more honest and robust research culture. All right, so now we're going to really start digging in more deeply into our topic today of data sharing and data publishing. So I'm going to launch a quick poll that's going to ask you all a couple questions about kind of your experience sharing data. So there's a question on how have you shared your data in the past, or how have you obtained others' data? This is a little bit older study, but I like to do this poll because I think it's a good indicator of kind of where we're moving as far as how we're sharing data. And it's really great to see, right, that in our little subsample, direct contact and public repositories are pretty much even now for how people have shared their data, whereas this was 2016, and we saw a lot more individuals indicating they were just providing their data via direct contact. So again, I think that this shows how the trends towards using those more established public repository infrastructures are really growing. And one of the reasons for this is that we have had a set of new guiding principles for what shared scientific data should ideally look like, called the FAIR guiding principles. So this stands for that ideally data should be findable, it should be accessible, it should be interoperable, and it should be reusable. And this is where we're gonna dig a little bit more deeply into FAIR during this workshop and during our exercise. But a lot of the things that repositories provide, so things like assigning digital object identifiers or persistent identifiers, are things that really aid in making that research object, that data set, more findable and accessible. Another big piece of this puzzle is data curation. So data curation is a term that can be defined kind of in various ways, but it's essentially those activities of managing data in a way that makes it useful to scholarship, science, and education. So this can include, appraising and selecting what data will actually be shared, representing the data, organizing the data. I would also add describing the data, particularly for this idea of access and use over time. So there's various different individuals who are involved in data curation. And I really like to think about it as a partnership between the researchers who are actively curating their data during a research project by adding necessary contextual information, formatting their data, structuring their data, and then the repositories that they're potentially going to work with when they post their data and make it publicly accessible. And we'll be talking about there's different ways to make data publicly accessible. We don't always mean completely open by that. That can be both data that's in a controlled access repository or in a completely open access repository. So we're going to be digging more deeply into these roles of both researchers and repositories throughout this workshop. So that's our general kind of introduction to the topic today, and some of the things we're going to be talking about. I want to pause here to see if anybody has any questions or comments before we start digging really deeply into specific good practices for data publishing. And I'm actually handing it over to Jen, so I'm going to stop sharing while we see if anybody has any questions or comments. Hey, if not, well, thank you all, and I am going to let Jen take it over. Yes, I will share the slides. I will put those in the chat right now.
Okay, folks, I will ask for your mercy and kindness because I'm getting over a cold. So if I have to stop and cough or anything, I apologize because I have to do a lot of talking during this section. So we'll see. I got water in hand and we will press on, as we say. So before we dive in on where to publish, I wanted to share a few things that are extremely important for optimal long-term viability and interoperability, or that fairness of your data. The first of these is, when possible, to use existing formal metadata standards. Standards are put in place to facilitate structural and content harmonization. So in other words, consistency across multiple data sets and systems. Some are discipline specific, others might be tied to the particular repository that you use. Nearly all formal standards provide documentation and even digital tools to help you integrate them into your work. It's always a good idea to look into what standards are available at the outset of your project, or what sort of expectations, if you have funded research, what they might have. Building an understanding of and incorporating these standards into your workflow early is far easier than trying to add that all in at the end. If you aren't sure if your field has a standard to follow, or if a particular repository expects a certain standard, you're welcome to reach out to Sophia and myself. So briefly, I'd like to show you two examples of some standards. The first is the NIH Common Data Elements Repository, or CDE. This is designed to provide access to structured human and machine readable definitions of data elements. So essentially a pooled set of standardized variables and values that have been recommended or required by NIH institutes and centers and other related organizations. You do have to have an account to use the CDE registry, but it's very easy to apply for. You do it as a research organization through Duke, very simple. I'm already logged in. So also, this is a live demo, so I am not responsible for any weird stuff that the internet does. Just want to preface that. So in looking at the CDE, let me pull up my fun notes for all the thoughts here. You can explore all the CDEs by their particular agency just by leaving it blank. You hit that search. The other thing that they've added lately are these NIH endorsed common data elements. So I'm just going to look at what those are. There's really only two right now, but what these like badged CDE collections are is that they have been vetted by an expert panel and they meet certain criteria. So for now, there's one that's a particular project for COVID-19, and then the other is the National Heart, Lung, and Blood Institute. I imagine these are going to be built more over time. So looking at all the CDEs, they have them listed by agency. So you can go ahead and browse if that's something that you want to do. I'm going to look at the National Institute of Neurological Disorders and Strokes. That's one I wanted to look at. So basically, their set includes some of the full questionnaires that they actually use in their research. If you click on a record, you can view the summary information about it. They can give you the definition. They give you the valid range values, things like that. You can get through more information about the classification. If you go down to the bottom of the field or the page here, you can see the actual instrument, which is really cool. One of the things that I will say is that the quality of CDEs can vary because the creator only has to include a minimum amount of information to publish. And I think at a minimum, if you're going to include coded values, it would be really nice if you indicated what they actually meant. I have seen some that they don't actually say that. I think you can assume sometimes one is yes, zero is no. But again, if you were to create your own set of common data elements, because they can do it by project. There are several that I've known that have done that. You want to make sure that you do define things really well, because this is serving as that metadata standard and that contextual information that's really important. So one of the things that I want to note here is when something says it's qualified, this means that the creator or steward of a particular project created the set and that it could eventually become a standard. So these are not like official. Those that are standard, that are listed as standard, because you can see here, you can select one or the other. Those have actually been created by the Common Data Elements Working Group. So another cool thing is with your account, you're able to pin different standards to a board. So that way, if you are pulling from different, say you're using different instruments or things like that, and you want to see what all of those, how they mesh together and what sort of things are required, those are great. You can actually add it to a board, save it, and mix and match as needed. So the second one I was going to show you, let me go back to my well, I don't need to go back to my slides. But the second thing I'm going to show you is specific to an NIH institute and its repository. So this is the National Institute of Mental Health and their data archive. It's a repository dedicated for projects that they fund. The NDA requires depositors to create a list of all of the data that you plan to collect as defined in their data dictionary structures right here prior to deposit. So this means, again, doing this at the outset, not at the end. It's very important. So their data structures dictionary, it contains over 2,000 data collection instruments and data structures that are commonly used in mental health research. So let's go ahead and explore this a little bit. I have like 5,000 notes in different places, so please bear with me. So the thing about the NIM data structures dictionary, it's completely unique to NIM. It is not currently included as a collection in the CDE library. In fact, they have their own common data element set that they have identified as ideal for use by all mental health researchers conducting clinical research. So their data dictionary is to be consulted to build your collection's data structure. So let's start here. Let's go ahead and do a search for depression. Oh, it only gave me one. Oh, it's a featured data set. See, this is what's fun is they give me different things at different times. And then when I go to search for things, it does it different. Anyway, one of the things that I wanted to show you is they do have, when you go to their, because I went really quick. If you go to their data standards section, they talk about their harmonization standards, what they require for all collections, how you're supposed to do it, the types of things you're supposed to include. It's pretty comprehensive. And they have the different kinds of data levels that you have to work with. So I'm going to go to their tools because this is what I wanted to search. And for whatever reason, they only gave me one. There we go. So now you'll see I have 83 results. And these are all different kinds of instruments that are used in clinical research on depression. So if you want to take a look at them, you can click on them to get a little bit deeper. They talk about what the different elements are, whether they're required or not. Required are things that have to be included. Recommended are things that you might want to include. You can search across and see how different things have been applied in different ways. So you see that's sort of how this works. If you want to see a particular variable and whether they're required or recommended, you can search the data elements, which is a little bit of a different thing. They have it and they mark it new. So here I'm going to go again and look for depression. And you'll see they have different things. They tell you what instrument it comes from. That shows the structures and distributions across different studies. So in any case, there's all kinds of different ways to work with metadata standards. This is just two that I wanted to show you. I'm giving you a very surface level view. I would say metadata can be very complex. So it's something that, again, you want to investigate early to make sure that you gain some familiarity. Perhaps you can talk to colleagues about how they've also used it, etc. So some other ones are the Data Documentation Initiative. This is one that's used in the social sciences. If you've worked with the Inter-University Consortium for Political and Social Research, ICPSR, that is the one that they happen to use. In the humanities, there's another one that is the Text Encoding Initiative's guidelines. And then a more general repositories tend to follow the Dublin Core standard, which is basically, I think of that in some ways like a standard catalog set to make it more easy to discover data using standardized terminology. And at the bottom of this slide, there is a link, and Sophia did share the slides, to a metadata standards directory on GitHub that is managed by the Research Data Alliance, which is an international professional association for folks like Sophia and I who assist researchers with data management and publishing. A resource like this is really helpful because formal metadata standards, as great as they are, can eventually stop being actively supported if the user community decides to change things or go a different way. With all that being said, it's entirely possible that a metadata standard might not actually exist for your field right now or your data type. Or the repository you plan to use, maybe they don't have discipline-specific metadata in their interface just because they're more broad in their discipline support. So in this case, you want to ensure that you have adequate documentation included in your data package that explains its content and context. Without this information, a data set is often unusable and potentially open to misinterpretation. A README file is the simplest and most flexible form of documentation, but it does have its limitations. This is where more structured documentation, such as code books, data dictionaries, protocols, and the like, can provide necessary contextual detail for working with the data. A formal metadata standard can be optimal for both data discovery and reuse, but again, they're not ubiquitous across all disciplines as yet. So another thing to consider for interoperability and long-term viability is file formats. While it's great to have data available in an analysis-ready format for you or for others to use right away, obviously we know software versions change, sometimes several times a year. Think about how many times you open Zoom and it re-updates. And some programs, they may completely disappear. So for long-term preservation and viability, it's best practice to also create a non-proprietary, open documented standard format of your data files. So these formats are typically uncompressed. They use a standard character encoding representation. Some of the examples are in the table in the slide. The most important thing is that you don't want to have too many embedded functions, codes, or macros, or other file dependencies that can easily break should that file be moved to a new environment. An explanation of those types of things are important to include in your metadata or documentation alongside a copy of your data set if you want to have something that's analysis ready that has all of those bells and whistles, but you also still want that more flat preservation friendly version. So that way, if things, you hope this lasts in perpetuity, that people can still get at that original data. If you aren't sure if the data format you're using is optimal for long-term use, you're welcome to contact us. So far, so good. Does anybody have any questions? Let me see here. I'm going back. Oh, thank you, Eric. Colds, man. So do I recommend any particular standards for art repositories? Not particularly. Sophia, are you aware of any?
Not off the top of my head. I know for some art, I'm actually looking right now at the RDA metadata standards, and so I might be able to find something on that list, and I'll put it in the chat. But not off the top of my head. I think the text encoding one is the one that I know that's most broadly used within the humanities that you already mentioned, Jen. But let me look in our resource that we have, and I'll see what I can dig up.
Okay, and then the other one, so the person for environmental sciences, there's a few. There's the Environmental Documentation Initiative, but I'm actually going to be showing here shortly a set of repositories that use basically a common set to allow for harmonization of searching across all these member node repositories, and it's all Earth and Environmental Sciences, so it's pretty cool. As for formats for Python scripts, I'm pretty sure that .py, they're fine as they are. I mean, I would say sometimes, you might want to have plain text versions, but .py is fine. And studies that use REDCap, yeah, I mean, they actually have some great stuff for you with that tool that will allow you to spit out the code books, which is wonderful. And you can also, yes, do different formats. You can do SAS, SPSS, STATA, CSV. It's a wonderful tool, and I'm a fan. But yeah, I mean, that's the biggest thing is if there are tools that you can leverage to make this process easier, by all means, absolutely. And there's a lot out there, and I imagine there will be more as we go on. So with that being said, because we have a lot to go through, I'm going to keep us moving. But if you have more questions, Sophia is monitoring the chat. So there are many reasons why you want to ensure you have a copy of your data in an open interoperable format. The obvious reason, of course, is you never know how viable software-specific formats are going to be in the long term. A software company can go bankrupt, or a program no longer be backwards compatible, or open source, that can actually fade. I mean, I think about things like WordPerfect and stuff like, what was another one that I ran into the other day? Minitab, like some other formats that are just kind of old, or they might still be supported, but they're not necessarily really interoperable. So for immediate ease of use, again, I think it's great to have an analysis ready version of your data, but you also want to have that open format in addition. So that's just an important thing to note. So there has been much discussion among funders, publishers, and professional communities around what makes a repository a good repository. It's basically very important that it's trustworthy for long-term preservation and stewardship, as well as how well it meets the FAIR guiding principles that Sophia talked about earlier. So linked here are several different approaches, including formal certification, a professional community assessment, and the U.S. Office of Science and Technology Policy, RFI, on this exact topic that was actually due way back early in 2020. So in all honesty, most professionally managed data repositories are going to meet the FAIR criteria, at least on a basic level. Disciplinary repositories, more often than not, are going to have more depth because they adopt community metadata and data format standards. So the repository landscape is becoming increasingly complex with a variety of options for researchers to choose from, including disciplinary and data type specific repositories, repositories built by funding agencies, either for particular projects that they fund or for types of data, as well as generalist repositories with different features. Duke researchers are using all of these different types of repositories to share their data, and our role is to help them find the repository that meets their needs and complies with funder and journal requirements. Something we've been doing a lot lately is reviewing NIH data management and sharing plans to try to make sure that that people are being led to the right home for their data. So again, the FAIR guiding principles are what led the NIH, as well as other federal agencies, to provide a framework for selecting an appropriate data repository. All of the points listed on this slide map back to one or more of the FAIR criteria. This includes unique persistent identifiers, such as digital object identifiers or DOIs. I've heard somebody call it a DOI, which I thought was interesting. Long-term sustainability, metadata, making sure you have adequate metadata, curation and quality assurance. So making sure that the data is accurate and well documented, and other things like making sure that it's in the appropriate type of repository by data type for security and protecting confidentiality, provenance, retention period, et cetera, and so forth. So when it comes to selecting a repository, we often use this decision tree. So if your funder provides or specifies a particular repository, this is definitely where you should go first. If you are publishing in a particular journal and it recommends a specific repository, then that's what you would use or choose from. I will note that some journal publishers are starting to drop the option of supplementary file storage that they once used to give people for lots of different reasons. They don't necessarily want to maintain it over time, and some people do have fairly large data that's not going to be able to be accommodated in these types of settings. So if nothing has been specified, but your field has one or more repositories where data are commonly stored and accessed, that's your next best option. So disciplinary repositories, again, offer the most robust metadata and facilitate interoperability across platforms. One thing you want to check, though, is whether a permanent identifier is assigned and that strategies are in place to avoid data loss over time. You want to make sure they have preservation and contingency planning. A web portal might be FAIR or offer parts of FAIR for the short term. Usually I say the FA in FAIR, but not necessarily the long term. In the event that there is no appropriate data repository for your field and your publisher or funder allows you to choose, we do have a local option here at Duke. We offer the Duke Research Data Repository, which is an interdisciplinary repository and available for all Duke research faculty, postdocs, staff, and graduate students to use. Sophia is going to talk a little bit about this later on. Finally, you also have the option of placing your data in a general repository, such as the Harvard Dataverse, Dryad, Figshare, or Zenodo. These repositories all offer varying levels of curation and features that you might be interested in. So what we're going to do now is go through a couple different repositories, do a walkthrough. The first two are discipline data type specific, and the last one is more of a repository network within a broader discipline of earth and environmental sciences. So let's go ahead and start that. So we'll start with PhysioNet. So PhysioNet is a very specific type of repository dedicated to physiologic signal data. To find about more information, what I always recommend to folks is look for an about. About's going to give you all kinds of good stuff. This should give you the background about the repository, its purpose, its funding sources, and who to contact for questions. So one of the things about PhysioNet is it has three interdependent components, including PhysioBank, which is their data archive, Physio Toolkit, which is a software library for data processing, and then also a collection of tutorials and educational materials as well that people can use for teaching and things like that. For funding and things like that, they give the whole history. They were initially established under the National Center for Research Resources in NIH, but now they have different support from the National Institute of Biomedical Imaging and Bioengineering. So that's great. And it's actually maintained at MIT. To share a resource through PhysioNet, and you can go ahead and click the share to figure out more there, they actually have a really comprehensive set of author guidelines as to what happens. So how you share, how the submission happens, what the editorial process is, how you're supposed to create your project metadata. So it's very specific. So in this case, the metadata here, this doesn't follow necessarily a disciplinary standard. This is more of the repository standard itself. So preparing your project files, they offer advice on how to name them, how to de-identify, how to format, and how to validate. When you deposit files, again, they do go under an editorial review, which is essentially a data curation review, to make sure that it's suitable for the collection. For the types of licenses that you can apply, they do offer information on the different types that they do support. So yeah, very, very comprehensive, very useful to look at all this stuff ahead of time to make sure that it's a good fit for you. So now let's take a look at some data. So they have different kinds of projects. They have open access, they have credentialed access, which is their most restrictive, and then they have restricted. So first, we'll take a look at an open access project. So you'll see that for when we're looking at the top of this, they provide a citation for the resource, but they also ask that you cite the original publication and actually the repository itself. There's an abstract. This is all of the metadata. If you go back and look at what they ask you to include, this is what all of that stuff is. They tell you what the license is, what the access policy is. They have the digital object identifier. And in this case, they have more than one version. So they have the DOIs for both versions and let you know which one is the most current. They have the different topics, which this obviously is a controlled access list, or not controlled access, I should say standardized list, that you can click on and get to other topics that are tagged with the same thing. Their open data is fully public and allows users to download everything as a zip file or using a command line or terminal. I will say that some of the data that's in here is big. This particular one, I think I remember when I looked at it earlier, not to make anybody nauseous with my scrolling, I apologize. But the data is all the way down at the bottom. And you can do some previewing, especially if it's text files and things like that, and some of the images. But if you really want to get everything, then you might as well just pull it all. This one's not huge. This is only 89 megabytes, but I have seen several in the hundreds of gigabytes. If we head back to a restricted study, let me see if I can find the one that I was thinking about. Here we go. Here's a restricted access study. You'll see that it has all of the same metadata we saw on the last one, has license, but then you notice here there's a data use agreement. It's not open for everyone. And they have the DOI versions. You can go through and you can look at all the metadata, but when you get to the bottom where the files would be, it says this is a restricted access resource. To access the files, you have to sign the data use agreement for the project. And then you also, of course, have to register for a PhysioNet account. Credentialed access is one step further. This is where you might actually have people do different kinds of training. In the case of this one, they ask for, I'm sorry, again, scrolling, trying to do it slowly so that it's not horrible. It's very long. But this is really great comprehensive information, is it not? This is why they ask for this type of information in the metadata. So you have to be a credentialed user, which there's a process for doing that. They want you to take a city data training course and then also have a data use agreement. So again, physiologic signal data, they have a couple other different things as well, something to consider if this is the type of data that you work with. So the next one I'm going to show you is FaceBase, which I love the name. It's funded by the National Institute of Dental and Craniofacial Research, which is within NIH. They have changed things around a bit since I last went over this repository in our last workshop on this. They used to have an about page, but they changed that. But they have a section in community And in this menu, it says new to FaceBase. This actually will give you a lot of the information you would need to get started to figure out, is this a good fit for the type of data that I have? What would I need to do? How do I submit data for FaceBase? How do I contribute data? Here's their documentation. They also have an FAQ section. So they have lots of information, even for basic scientists, if you're doing, basic science research, or if you're a clinician researcher and you're dealing with human subjects data. FaceBase offers both controlled access and open access. And then also if you're a student, it's they've really done a lot of work. I think a lot of places have since the NIH policies went into effect. So like, for example, if you mouse over contribute, you will see that they have information about why you would want to contribute, overviews and advantage, but also how to incorporate FaceBase into your data management and sharing plan. So that's also very helpful when you're drafting plans. If you know what repository you're going to use, some of them, like this one, will provide you with the language that you need. If you want to submit data, they have a whole section on how you would go about doing that. They have an online submission form. You actually have to be pre-approved to share your data. So, and they also have their current data priorities. So there's certain areas where they're really hoping to get more and more collections in that area. So this is something really to take a look at. And then they have the whole process with documentation as to how you would submit. So it's pretty comprehensive, just like PhysioNet. So we can go ahead and take a look at a data set. So very complicated browser. They offer several ways to narrow down what it is you want to find through different kinds of filters, which is really helpful. So let's say, we're particularly interested in things on zebrafish. Obviously, you can drill down further, but I'm going to keep this simple because I'm not a craniofacial researcher and we only have so much time. So you'll see each data set is assigned a record ID. If you click on the record ID, and actually I'm going to go to the next page. Because there was a cool one, this one. This is that record ID, TYT. If you click on it, it takes you to the actual data set record. You'll see that they have an accession number as well, in addition to a DOI. They give a description. And what's really, really amazing is if you have imaging data, it actually gives you the previews, which is very nice to see. They have different sections that pertain to different areas of data as to whether, like, if there's genomic data, they include a certain thing. If the data is part of a larger project, it'll tell you through here where it says project. So this is part of a larger collection that is the Anatomical Atlas and Transgenic Toolkit for Late Skull Formation in Zebrafish. If you click on that, it'll get you to the landing page for the project and then all of the data sets that are associated with it. The interesting thing here that FaceBase does, as opposed to what PhysioNet does, which is mainly assign a DOI to the data set at the collection level, these will assign a DOI at the project level as well as at the data set level. So depending on how you're labeling things in manuscripts, if it's important that people get to your larger project or collection, you can list that DOI. Otherwise, if it's more important that people get to drill down to a specific data set, you can use that particular DOI. Let me see if I missed anything that I wanted to show you. Let's see. I go back to data sets. So like I said, they do have controlled access versus open. And they even have a section here as to whether something is protected human subjects data. I'm going to click yes, so that you can see what that looks like. And this is one where it gives you a lot of the some of the supplementary files and things that you can look at, but you can't necessarily easily pull the data without putting in for an application first. And then the last one I want to show you again, is a network of repositories called Data One. This is the Data Observation Network of Earth. So Data One is a hub for 51 member repositories that contain research results from disciplines in the earth and environmental sciences. While each repository is its own distinct resource with its own terms and conditions, Data One allows them to leverage technology infrastructure as well as those shared metadata standards to allow for federated searching, which means why search one repository at a time when you could search them all? If your research falls within earth science writ large, it is worthwhile to take a look at the Data One repository list to see if there's one that would be an appropriate home for your data. They collect extensive metrics as well across the network, including total data sets, how well the metadata in Data One stacks up to the FAIR metrics, citations, downloads, and more. It's kind of amazing. But yeah, if you are interested in all of their different repositories, click on member repositories, and perhaps one is even familiar to you. I love how up front they have the downloads and the dataset views, very fancy. But you'll see here, these are all the different repositories that they include. The Environmental Data Initiative, which actually does have support of metadata standard that goes across these, is one of the member nodes, as is Dryad, actually. Dryad is considered a generalist repository, but it got its start in the life sciences as well as environmental sciences, so that's why it's included here. But anyway, like I said about federated searching, let's go for finding some data. So I'm going to look for puffin because I was in Alaska not that long ago and I got to see these guys up close and they're adorable. So each result has an icon in front telling you which repository the data comes from. But given the shared infrastructure, you can access everything from here. So let's take a look. What do I want to do? Let's see, marine bird survey observation and density data. So this tells you where it comes from. This is the research workspace repository. This one here has a DOI at the top and an even longer DOI for the particular version, which is interesting. Some of the repositories that are in the Data One member network don't necessarily have a DOI, but they have other persistent identifiers that they use. Again, that's typically always going to be presented at the top. There's also a citation generation button that you can click, and it'll give you what the citation is and to copy it to the clipboard. Really trying to encourage people to make sure that they cite things that they use. The interesting thing about this one, as opposed to some of the other repositories, is it gives you the data right up front. So like as opposed to like FaceBase and PhysioNet, which had it all the way at the bottom. So in this case, the data is right up front, but then the metadata can be found below. And these are the different kinds of things that they include. All of the different data sets in Data One can leverage the different kinds of standards that they have to make sure that people can find it. You'll actually find that the metadata in some of these can be really quite deep. And some of them will actually allow you to drill down through links as well. But again, it depends on what field it's from as to what exact metadata it actually uses. But in any case, that's just to give you an idea of the different flavors of data repositories out there. Believe me, there is way more. Just to make it even more complicated, there's indices that you can use to search for repositories, including the fairsharing.org site and re3data.org. Nature also has a disciplinary repository list, and of course NIH has their own supported scientific data repositories, which is also a huge list that you can do by sub-agencies. The biggest thing is if you're not sure where to start or it's overwhelming, you're welcome to contact us for help. We're always happy to assist folks. So take a moment, take a stretch, see if anybody has questions before we start our exercise.
So now I'm going to say just a little bit more about the Duke Research Data Repository. So Jen already mentioned this as an option for if you don't have, a good disciplinary repository that your community is already using, or if there isn't one that's being supported by your funding agency, then the Duke Research Data Repository is a potential option. We do want to always note that the RDR is completely open. So for those use cases that said, there are some risks or the data is somewhat sensitive and they need to have access restrictions in place, we cannot support that and currently within the Duke Research Data Repository. But again, we can help you think of other options if that doesn't work. So now I'm going to say a little bit more about curation within the Duke Research Data Repository. Because I know that this can be somewhat invisible work at times. So again, curation can vary across different repositories. Some of the generalist repositories we talked about, such as like the Harvard Dataverse, all of that is self-curation. So really, you as the researcher are going to have to be doing all that work to prepare your data and make sure it's well described. For any data that comes into the Duke Research Data Repository, Jen and I do a general review of those data sets before making them public. So just to quickly go over what we do. So one, all data sets do receive that DOI, that digital object identifier. And the first thing we do when we get a data set in is we try, if we have the software, to actually open the data files and kind of validate the contents. What we think should be there is what's there. And then we do a check of the documentation. So we want to ensure, there's sufficient information for someone with similar qualifications to understand and properly interpret the data. We look at the file formats. We've talked a little bit about interoperable file formats and see if we have recommendations for transformations. And then we do perform a disclosure risk review. So this is really to help to protect against the disclosure of any sensitive data or information inadvertently. So we'll ask for a copy of the consent form to make sure it allows for data sharing or does not specifically preclude data sharing. We'll look for those direct and indirect identifiers, primarily the ones identified in the HIPAA safe harbor method, those 18 identifiers. I do want to say we do not de-identify data for people. We also cannot certify that as fully de-identified. We are not honest brokers. We are just trying to provide kind of that second set of eyes to make sure that nothing is inadvertently disclosed. Might normalize that metadata. We do use that more general Dublin core for discovery. And then there's other kind of data or code enhancements we might identify. And just want to really acknowledge that communication with the researcher is super key during this process. So we don't make changes to a researcher's data sets. We really just see if we have recommendations for how to optimize it. And, our focus is providing that second set of eyes. We do have some submission guidelines and a curation checklist to also help people as they're preparing their data. And again, just important to note, different repositories are going to have different expectations for the structure of the data and the kind of depth of curation. So Jen already talked about, the NIH common data elements and the NIM data archive that has a very specific structure. They want that data dictionary in. They have specific structures for the data. And some of this is about harmonization of data as well. So just again, an important thing to note as you think about identifying repositories, understanding kind of that curation that's provided. So we've already kind of surfaced a few of these during the exercise, but this is a table of different repositories that Duke either maintains. So we primarily just maintain the Duke Research Data Repository, or that we're members of and kind of pay a fee or help to maintain. So I'm not going to go through all of this, but we already talked a little bit about the qualitative data repository. ICPSR is that large social science data repository. We're also a member of Vivly, which is a general clinical research data repository. And that is all controlled access. And then Docker maintains a collection within Zenodo that's particularly been approved for Duke patient data that is coming under things like a waiver of consent. So where there hasn't been specific consent given for sharing that data, and they can work with individuals in that use case. All right, so I'm just gonna wrap up now by bringing it back to. We've talked a lot about kind of the mechanics of sharing data via the repositories. Just want to acknowledge that doing this work, it oftentimes does require some extra work, but it can have some positive impacts for for your own research. So there has been research that's actually shown that if you put your data into a data repository and link to it within your article, you're going to get a 25% higher citation impact for your article. So this is real world data that's showing the real world positive impact that data sharing can have on your career. Likewise, so not only, increasing potentially the citation impact of your article, but you get that data citation for your published data set that then you can put in your CV, you can put it in your bio sketches, and you can really use that to demonstrate how you are contributing to the open science and open scholarship movements. And again, I just want to reiterate, Jen's already said, it's good normative practice, regardless of what license is assigned to a data set, to always cite any data that you are using fully, and to also have that full citation for your data set. So there's a set of kind of principles around data citation that also came out a few years ago. And it's really trying to communicate both kind of what's important as far as the structure of a data citation, as well as what's important about those practices. So things like, yes, let's fully cite data sets that we use and use kind of that fully structured bibliographic citation structure. Another kind of good practice that's been coming about over the years is this idea to actually put those structured data citations in your reference list for an article. So, there had been kind of a common practice. Sometimes people would just like put a footnote of, oh, I found my data here, right? But instead, you want this structured citation with ideally your DOI, because that allows us to more easily also track the usage of that data over time. So again, some journals are starting to require this practice. Some maybe haven't gotten there quite yet, but I do think, again, this is the trend for how we want to amplify data as a standalone research object. I also just want to note this example, when I pulled it together, was interesting because you can see here they actually have a URL in this data citation. And when I clicked on it, it took me to a 404. So it's a great example of why we want to use those persistent identifiers, because URLs can break over time. So again, just to kind of wrap up, one of the end goals, especially if we're thinking about publishing data that's underlying a research article, is to create that connection between the data in a repository in the research article by linking the DOIs. You'd have kind of that data citation for the data set with the research article, and then with the data set metadata, having that citation for the article. So again, just having that bidirectional link. Okay, so a question did come up around, like sharing code files. We didn't talk about that a lot today. We were very focused on data. Again, a lot of repositories, you can just kind of include code files alongside the data. But if you're already, very involved in coding and using a platform like GitHub for sharing some of your code, one of the things we'd like to encourage you to consider is actually archiving a copy of that code. And there's this really nifty integration with Zenodo. So Zenodo is another generalist repository. It's kind of that you can post any types of materials. It was developed by CERN. It's a very long-standing repository. And they have a cool integration. So essentially, you can easily zip up a version of your code files that are in GitHub. So that's kind of like a snapshot or milestone of, when that code was generated, potentially, to replicate certain findings in your research, and archive it in Zenodo. So, you also have a safe copy, and then you can get a DOI for your GitHub repository at that point in time. So again, it's a really nice workflow. There's other ways to do it. You could always just, zip up a copy of your code files at that point in time and put it into other repositories. But I just really want to encourage you all to think about, not just sharing, but sharing again in a way that you get that persistent identifier and you're sure that the data or code files are being maintained by an organization that wants to, has that future view of making it accessible for the long term. So again, this is just, I like this visual of, this is kind of the end game of some of the things we've been talking about today, is making your research workflow transparent and being really clear of, okay, I've published this great research article. Now here's how you can go find my data in a data repository. And here's, my code in GitHub that's maybe been archived in Zenodo. And here are any of the tools or software that I've developed. So again, we can have this really transparent and reproducible research culture. So again, like this visual, there's some really cool, again, this is also under a CC BY license. And if you're interested in this topic, I definitely encourage you to check out, they have some really nice illustrations and they are archived and available in Zenodo. Really awesome. And we do thank you. And yeah, if anybody has any follow-up questions, you can reach Jen and I at datamanagement@duke.edu. We're happy to set up consults to talk about your kind of individual data, individual needs.